Hi, today we're going to be talking about graphing proportional relationships. This is going to be very important when we talk about graphing things later in this chapter. But first of all, the first thing that a proportional graph needs to have is it needs to be a straight line. In other words, it needs to be linear. The other thing it needs to have is it goes through the origin. This is unit rates equal. Very, very similar to when we were talking about regular proportional relationships yesterday. So let's look at example 1 here. We're going to be graphing this set of data. It says time and cost. So the bottom row is always the output. Always the output. And the top row is always going to be the input. In other words, this is the x, and that's the y. So the first thing we're going to do is the first ordered pair is going to be 1, 10. So I'm going to go over to my graph and look for 1, 10, and that's right here. Next ordered pair is going to be 2, 15. So I go to the right 2, and up 15, and that is where that's going to be. Number 3 is going to be 3 and 20. 4 and 25, 5 and 30. Finally, the last thing that we need to do in this case is we need to connect those ordered pairs with a line. So first of all, it's pretty clear to see that this is linear, so it satisfies one of the two requirements. But the other one, it does not use the origin as part of its data set. It does not go through the origin, which means that this is not proportional. Because it does not go through the origin. Or 0, 0 is not a part of this data if we were to continue it off in one direction or the other. Example 2. Same thing here. We're going to be looking at how much gas is used in gallons, and we're going to be talking about how far something goes in miles. So again, this is my Y information, and the gas used is my X information. So if I go over to my graph here, first ordered pair would be 1, 25. So I go to the right 1 along the x-axis and up to 25. That's right here. The next one is over 2 up 50, over 3 up 75, 4, 100, and 5, 125. I'm going to use my ruler here again to graph and connect these dots with a line. And in this case, it is linear, and it is proportional because it goes through the origin. So this is proportional because it's linear and goes through the origin. Again, 0, 0 does count for part of this set of data. For example, we can see that the rate of change here from 25 to 50 is a plus 25, and from 1 to 2 is a plus 1. So if I wanted to go back to 0, I'd have to go back 25, and 25 minus 25 would also be 0. Now we can start talking about how we can analyze proportional relationships. So again, in a proportional relationship, the point 1r tells you the constant of proportionality. Is r. Recall from yesterday with lesson 5, the constant of proportionality is essentially the rate of change or the unit rate in a proportional relationship. In this case, we're looking at 1r, and r is the same thing. So let's look at example 3 here. So the graph shows a proportional relationship between fathoms and feet. Find and interpret the constant of proportionality is part A, and then part B is explain what the following points mean, and we'll get to those in a moment. So it says, first of all, find and interpret the constant of proportionality. I want to look for what 1r is. So 1 is about right here. So I'm looking for this point right here. And I want to figure out what that missing number is in this ordered pair. So first of all, I want to look at how do these numbers change with respect to each other. In other words, 4 gets me 24, how? 8 gets me 48, how? 12 gets me 72, how? And I can do this because it's proportional. And things that are proportional have a constant of proportionality. So if I take 4, how do I get it to 24? Well, I would do 24 divided by 4. And that is 6 over 1. Which means that this last part of this ordered pair is going to be 6. So the constant of proportionality is 6. So my ordered pair is 1, 6. Now, the other part says to interpret. This 1 represents the x values here, and that is going to be fathoms. So I'm going to write down 1 fathom is 6, and this is my y information here, so I'm going to look at the y-axis, and that is in feet. So 1 fathom is 6 feet. Last part here, explain what the following points mean. 424, 848, 1272. Well, if we look back at part 1, 1 fathom was 6 feet, so 4 fathoms is 24 feet. 8 fathoms is 48 feet. And 12 fathoms is 72 feet. Keep in mind when we are doing this, all ordered pairs are listed as x, comma, y. So this would be x, comma, y. So again, the x values, according to the graph, is in fathoms. The y values, according to the graph, are in feet. So the number that is in the x place represents how many fathoms. The number that is in the y place represents how many feet. So keep that in mind as we are going through and graphing in the future. If anybody has any questions, please let me know. Otherwise, this is the end of lesson 6.